once again welcome everyone to our webinar series. And as I said, Jackie Michel is going to give us a talk. And you can see her title on the screen, A Brief but Spectacular Story About the Creation of the Environmental Sensitivity Index Shoreline Ranking concept. And so before I turn it over to Jackie, just remind everyone, I think we probably have mostly attendees that have heard this spiel before, but we're going to let Jackie speak for as long as she needs, but it's probably going to take around an hour, and then we'll save 15 minutes or more for questions. The attendees can, if you go to the Q&A button in Zoom, you can ask questions through the Q&A button. The chat button, I'm not sure the attendees can even see the chat button, but the chat button is only for the panelists, which is Jackie, myself, and Lynn. So if you want to ask questions, open up the Q&A button, and I see that somebody's already populated it. And ask your questions as Jackie goes through her slides, and then at the end, we will read through the questions, assuming we have enough time, and we usually get through all the questions. And it's been taking about half an hour, so Jackie has kindly agreed to stay after the end of her talk until at least half an hour until we get the questions, many of the questions answered. So with that, I'll go through a quick bio. I'm always humbled when I read the bios of the speakers we've had on this webinar series, because it makes my resume look pretty meager in contrast to it. But so Jackie, Dr. Michel, she's president of Research Planning, Inc. She is a geochemist specializing in terrestrial and marine pollution studies, coastal geomorphology, and environmental risk assessments. She's worked in 34 countries, has extensive international experiences, and has worked in many different coastal and terrestrial environments. Dr. Michel is one of the founders of RPI and president, as I said, since 2000. She's been part of the NOAA scientific support team, providing 24/7 response capability since 1978. Because of her routine scientific support for spills, she has extensive knowledge of and practical experience in pollutant fate, transport, and effect issues. She has written over 250 manuals, job aids, reports, books, and scientific papers on a wide range of coastal and marine resource management, oil spill assessment, planning, and restoration, which is very impressive. She has conducted hundreds of training courses on the SCAT process. Dr. Michel has been recognized for her achievements through appointments to many respected committees and panels, including 7 National Academies committees. That is very impressive too, because I know how much work goes into those.
Yeah, a lot.
Yeah. Full-time job in addition to your other full-time job, probably for months. She was on the Ocean Studies Board at the National Academies from 2001 to 2005 and is a lifetime associate of the National Academies. So with that, Jackie, I want to thank you for volunteering to do this. I know your talk is going to be very interesting, so I'm going to turn it over to you.
Okay, well, great. Thank you. Good morning, everyone. I'm actually giving 2 talks. I'm going to start off with this brief but spectacular story about the creation of the Environmental Sensitivity Index, or ESI, shoreline ranking concept. And then I'm going to go into the most sensitive shoreline habitat, marshes, and talk about oil behavior, cleanup, impact, and recovery. But I'm going to dedicate this first part to Miles Hayes. He was the one who came up with the idea of the concept of the shoreline ranking systems, and he was my amazing husband for 46 years, and he passed last March. So he got his PhD at the University of Texas at 64, studied under a very famous sedimentologist named Robert L. Folk, and he started studying the coast of Texas, and then he went to UMass and formed the Coastal Research Group from 64 to 72, and started doing work in Alaska. So he had a lot of work in the New England area and the Alaska studies. And then the University of South Carolina encouraged him and invited him to come down to South Carolina and set up a program there. And he set that program up from 72 to 84 when he resigned because the company of Research Planning was doing so well. So he was doing work in South Carolina, the Caribbean, New England, Alaska. And then in 1975, he got a call from the National Science Foundation, a guy named Ralph Perhack. I remember it well. And he called up Miles and said, there was this oil spill in the Strait of Magellan. And this was right when they were building the Trans-Alaska Pipeline and the ultra-large crude tankers, carriers were coming into the New England area, and they said, we think you'd be a great person to go down there and see what we can learn about the Metula oil spill, so that we could be better prepared for spills in Alaska and New England. Because essentially it was a large spill, 16.5 million gallons, and not any oil was removed. They just removed the tanker. It was right after Allende had been shot in Chile, and so they just left. And so Miles put together a team that went down there, and it was amazing. You know, it's glaciated shoreline. It's got big tides like Cook Inlet. You know, the tidal range goes up to 10 meters. Big gravel beaches, and just so much to learn from. And so this was back in the days when you actually went to oil spills and did research on it. And so we've found, you know, these are two pictures. Here's oil penetrated deeply into a sheltered gravel beach. Nice, and that's still there. People still go down and study it. And then oil penetrated deep into a wetland area here. And again, Eric Gilmack just did a paper 40 years after the spill for the International Oil Spill Conference. And then, you know, with an NSF grant, you know, you ask forgiveness, not permission. So just as that summer, we read in the paper about this live oil spill in Spain, the Urquiola. And so a team jumped on the plane and went to Spain for several weeks to study that. And this was 3.3 million gallons of crude oil right here in this is right in the northeast Spain. The vessel caught on fire and released oil inside this ria, or drowned river valley shoreline here. And we had different kinds of tidal flats and different grain sizes of beaches and offshore rocky coast. And you can see here in this picture, look at here the oil on this rocky coast here that's exposed to wave action. The oil is being held offshore by the reflection of the waves. And then there were many different grain size beaches. And so we were able to document how oil penetrated variably based on grain size, and then also got buried. So we started learning about that. And then just a few weeks after coming back from Spain, we had a project in Lower Cook Inlet for the Alaska Department of Fish and Game, because, you know, there was the oil exploration in Cook Inlet, and they wanted us to sort of come up with some ideas for how to do oil spill planning. And so we went out and did all these. God, Lower Cook Inlet is the most amazing place. And so we got to see big mud flats and gravel beaches and exposed rocky shores. And then Miles came up with the idea. After that survey, he came up with what we called it originally the vulnerability index. And so we had a 1 to 10, went from, you can see here, straight rocky headlands, wave cut platforms, fine grain sand beaches, coarse grain sand beaches. We had tidal flats as number 5, mixed sand and gravel as beaches as number 6, gravel beaches as 7, sheltered rocky, protected tidal flats as 9, and salt marshes as 10. So then in 1978, we had been communicating with the original NOAA hazmat team, and they got some money funds to go over to France in 1978 to study the Amico Cadiz spill, not to assist them, but just to learn from it. And so again, another team went over there to study that, and we had 320 kilometers of shoreline oil and all kinds. And this oil, the Amico Cadiz lost power and then broke up on the rocks. So, and a lot of wave action. So there was a lot of naturally dispersed oil. And what we learned here again was that on this is a tidal flat here where there were over 3 million dead cockles and razor clams. So we said, tidal flats maybe should be a little higher on the scale, and many other things we learned. And so in 1979, the Itchtop blowout occurred. And I remember those of you who remember Jerry Galt and John Robinson, they were the original hazmat team or ERD team. And we were down in Texas, and Galt had said, at a big meeting with all the command there, and he said, well, oil's going to start coming ashore and across the US border in 10 days. And I remember John Robinson turned to Miles and said, hey, Miles, this is a chance to test out your sensitivity mapping concept. And Miles said, but John, we haven't made the maps yet. He said, well, you got 10 days. And so we ran around, Miles flew in a helicopter, and we came up with this scale for Texas. There's no rocky shores in Texas, but there are erosional scarps, and they're pretty similar. And then we had fine grain sand beaches, so we're kind of we still have low biomass exposed tidal flats. And then we have mixed sand and shell beaches. And so we bumped up flats. Now we have 7 that's tidal flats because they're the high biomass. Okay. And so this is the very first map, ESI map ever made. Pretty simple and hand colored because now we do it all with GIS and it's very complex data sets. So this is the shoreline classification system that we've been using since essentially the 90s. We have color coded. It goes from cool colors that are less sensitive to warm colors that are most sensitive. We've got exposed, solid, both natural and man-made shoreline types here. Sand beaches go from fine to coarse to medium. Fine to coarse to mixed sand and gravel because oil penetration and burial is very much of a function of grain size. And then we still have tidal flats now have moved up to 7 and have always been between sheltered, and then 9 are the 7 is the exposed tidal flats and 9 are the sheltered tidal flats. And then we have more types of wetlands, from salt water and brackish water marshes to fresh to swamps to mangroves and scrub. So that is how the shoreline classification was evolved. It came through just practical empirical observations at spills. Okay. So now that's going to give me a good way to segue into the highest sensitivity of all habitat, marshes, ESI 10. So I'm going to talk about the behavior, impacts, response options, and recovery. So I'm going to talk just a little bit about marsh types and then why we care about them. I've got the factors that affect how oil impacts marshes organized by 7 or 8 different factors. Then I'll follow up with what we normally try to do to clean marshes that once they're oiled, and what kind of recovery rates do they have. Okay, so what is a marsh? Well, it's a transitional area between land and water. Any place that's holding water that has non-woody vegetation. So it's mostly herbaceous. It's a low wetland, often treeless, periodically inundated, with grasses, sedges, cattails, and rushes. So here's a good picture of one in Georgia. And we care about them because they have many important roles and services. Their habitat, they are food source, they're a nursery, they filter water quality, they absorb nutrients, they recycle nutrients, and there's many more things they do. People love to go, people recreate in them. They're very valuable, as we all know. And they vary quite a bit around the world, but in North America, we have the top cross section is your typical Atlantic and Gulf Coast marsh system. So where you start off in the subtidal zone, you usually have smooth cordgrass, spartina grass that's tall on the edge and shorter on the inside. Then you can have some salt grass and cordgrass and needle rush and things here. But on the West Coast and on the Pacific Coast, including Alaska, you get different species. You get pickleweed and silverweed and these other kind of species that they're not as tall. So it's they're very different, and they will have different sensitivities. And so here's some pictures of the types of marshes. I can always remember the name of Spartina alterniflora because the leaves alternate on the stem. And most salt marshes are not salt obligate. They grow fine in fresh water. They just get outcompeted by other vegetation. And so they have developed ways to exclude or extrude salt. So here's a close-up of a blade of spartina grass where you can see the salt crystals. So they extrude the salt crystals so that they don't cause damage to the cells of the plant. And therefore, certain species have developed tolerance to different types of salinity. Not in the water, it's the ground, it's the pore water salinity. So oftentimes in salt marshes, you'll have these monospecific stands. So this is all pure Spartina alterniflora here. Here's a zone of Salicornia and Borachia. All these are salt tolerant species, but they just have different levels of tolerance. The Spartina grass outcompetes all the other species in terms of when the salinity is the highest. And there's lots of animals, there's lots of ecological resources in these salt marshes. I love this little picture of the salt marsh harvest mouse, which is a listed species in California, and whooping cranes and all these other things that we love to eat or watch. And so now when you have an oil spill, you know what we always try to understand, what the impacts will be, what kind of natural recovery is, and then what are the best options to speed that recovery rate. And so we want to look at the effects of the oil on the habitat, the animals that use that habitat, and then off-site impacts. And we're trying to trade that off, those kind of impacts with what can we do to speed recovery, and what kind of cleanup do we want to do or not do. Because when you get people in a marsh, there's going to be trampling and mixing oil in the soils and disturbing the surface soils, and that causes smothering of the vegetation. So here's my 7 factors that we look at briefly to sort of how they might affect impact and recovery of a marsh that is oiled. Oil type is number 1. And boy, we were learned really early on, in the 1970s, there were a couple of spills, actually in the 60s, there were a couple of spills of number 2 fuel oil in Buzzards Bay, pretty large ones too. And of course, Woods Hole Oceanographic Institute is there. And so there was a cadre of scientists who went out and studied that. So here's a picture of all these dead polychaetes. I mean, this is just, they weren't collected. They just all died in that one depression. And so the number 2 fuel oil, especially when it's released in a confined area, it can be transported to a marsh in thicker concentrations, because usually number 2 fuel oils, diesel, home heating oils, they spread to pretty thin slicks. But if you have something that constrains that spread, then you can get much more loading into the marsh soils. And so all of these spills killed extensive of the amount of vegetation. I mean, very quickly too. So here's some pictures from that 70. One of the spills in Buzzards Bay. So the pictures on the left are before, and the pictures on the right are 2 years later. Okay. So you can see the vegetation was killed. I mean, it didn't wither, it completely died. And especially in New England, once you kill the vegetation, that peat platform in which the marsh is growing gets eroded, and it's lost forever. And there's some people who do laboratory experiments, especially there's Irv Mendelson and his crew at LSU loved what I used to say torture plants. And they would take these plants and put them in greenhouses and pour oil on their soils or on the vegetation. And this just shows this is a number 2 fuel oil. There's a really nice dose response in terms of the degree of oiling in the marsh soils for both above ground biomass and below ground biomass. And then some researchers in Texas did some similar studies. This is a kind of complex diagram because it's 3-dimensional, but essentially they studied the effect of contamination of the vegetation. They poured it on the vegetation and on the surface of the soil for Arabian oil, a Libyan oil, a number 6 fuel oil, and a number 2 oil. And then this is in this direction is the amount of oiling. So the one in the back is no oil. This is 1 liter, 1.5 liters, and 2 liters. And then this shows the above ground biomass. And so you look at the little red thing here, that's the number 2 fuel oil that killed most of the vegetation at very high loadings. It supports what we know already. So lighter oils are much more toxic, acutely toxic. Now, the next factor is the extent of contamination on the vegetation. And, I love these time series photographs because, they're almost better than, laboratory studies because they're so realistic. I mean, this is not laboratory studies, suffer from the fact that they don't have the natural removal processes and all the things that are going on in the field as opposed to in the lab. So here's a spill of a heavy fuel oil in the Cape Fear River. And here is some oiling on the marsh vegetation, and we went back, but you notice it's kind of light, but all the upper part of the plants are not oiled, and the leaves of the plant are what you respire through those, and so this marsh here recovered pretty well. So you can just sort of see here's the church steeple in both of them. So we had little to no impact, and we did some studies, but I think the pictures are almost more valuable. Here's an area with a little bit heavier oiling and thicker oiling on the vegetation. And so 2 years later, there was some partial dieback. Here's a spill in Lake Boray, one of the areas of the highest land loss in the United States. And there was a pipeline release that went straight into a marsh, but the water levels were high throughout the whole period, and so there was no soil oiling. So it was just on the base of the vegetation, and they did some natural resource damage system studies, and there was no impacts to the vegetation because just the lower part of the plant, not the leaves and not the roots and soil, were oiled. And then here's Reverend Mendelsohn torturing his plants some more. So after Deepwater Horizon, he did some more field experiments where here's Spartina alterniflora. So here's a plant that was 100% oiled on there, and that had I'll show you some data some more. And then he did the same thing with Juncus bromerianus, black needle rush, and you can see, again, this is the 100%, and then they did a 70% repeat oiling. And so the pictures are not as good as this case as the diagram. So here's their plot where here's the control, here's 30% oiling, here's Spartina is the white and Juncus is the black. 70% oiling, the Juncus is having more effect because it's really it's got just one blade. It doesn't have leaves on a stem. So it's got, when you affect the surface area, you do it more, it affects more of the plant. So we had 70% repeat oiling. We had, less than half of the stem density, and then 100% of the oiling, with the Juncus, it's between 70% repeat oiling and then 100% oiling. The Juncus was always more sensitive, but when you oil just the soil, they were about the same. So they have different impacts depending on how much of the surface area of the plant is oiled and by degree. Okay, so here's another way of looking at degree of oiling, again, from the Deepwater Horizon. These are some studies that we have done and followed for years. Scott Zingle has been the lead on that. And so we have the marsh edge, which is in blue. And so here, what this line is, this horizontal line is like the control, what it would be as a control. So right after the spill, we had a drop in response for above ground vegetation, biomass. So it dropped down to about 60% below normal. Then over time, but within about 4 years, it was the marsh edge had recovered at all sites. And then even if you look at just the heavily oiled sites, this 1, 2, again, after about 4 years, it had recovered. And these were some very heavily oiled sites, marsh on the vegetation and on the soil. And the interior, but the interior side, once you get oil inside, it's not exposed to those, as much to the effects of tidal flushing and wave action. So the interior marshes took longer. So degree of oiling is an important factor. And then the next one is the degree of contamination of the soils. We always try to minimize foot traffic in the marsh because we don't want to get the oil deeper into the soils. And so here's some work, again, by Reverend Mendelsohn and Dr. Lin. So he's measuring TPH 7 months after the spill, and then measured the above ground biomass. So as the oil went up, the biomass went down. So we got to keep the oil out of the soils. On top of the soils is bad enough. But then one of the most important factors that I think about is, what are the natural removal processes and how they work or don't work. And so one end member is the Matula spill. Here's I didn't take this picture. I always laugh. I said, they took the picture right before the airplane was crashing because the horizon's not level. But here's an aerial photograph. Remember, the spill occurred in 74, and this photograph was taken in 76. And of course, the oil was on the water long enough, so it went on a spring tide. The oil came up. There's only 2 or 3 little marshes like this here. And so the oil entered the marsh, and during spring tide, flowed over the marsh platform, and then covered wide areas outside the channels. So you can see all this oil here. Again, no cleanup whatsoever. And then here, what it looks like on the ground. This is again 2 years afterwards. The vegetation is dead because it was pretty blackened, and it's pretty thick on the surface too. And so here's another photograph from 74 and comparing. This is an infrared photograph taken in 81. And so we've got a few places where there's some live vegetation trying to come back, but essentially And that's only where it's been able to find some area where it kind of the vegetation grow and die, and it had a little layer of organic material separating the vegetation from the oil. And then Eric Gunlack has been there as recently as 2017, and you can see here that there's very little recovery. So when you have really thick oil on marsh surface and no natural removal processes, it doesn't even rain there hardly. So it's an arid environment. So what are the natural removal processes? It's cold, it's dry, it's thick. It's we always say that eventually this will it will be a little oily layer in the geological record one time, because it won't be able to be weathered. And so here's a shovel. You can just see what the oil looks like. It's hard on the outside, but still mousse-like on the inside because it's so thick. Now, another end member of this is the spill from the Amazon Venture. It was a spill in the Savannah River. And the Savannah River is right there at the apex of the Georgia Bight, where the tidal range can be up to 12 feet, during the spring king tides. And so the tidal range is pretty big and the currents are pretty strong. And you can tell that here. Here's some poor people trying to pull a boom with this teeny little boat, and that's way too much boom. It wouldn't even safe. You can see they're trying to pull that boom out, and you can see how strong the currents are because the oil is flowing from the top of the photograph to the bottom. And you can, right here in this area where there's no oil is where the oil's been entrained, but it pops back up to the surface once it gets beyond the boom area. Big currents and big tides. And so this was 500,000 gallons of a heavy fuel oil, and inside the Savannah River, and the Savannah River actually trifurcates. And so the oil just went everywhere, and almost all the entire shoreline where the oil came ashore was wetland. So there are over 650 acres with moderate to heavy oiling and 690 acres of light oiling. And I remember we sat down, I don't know if any of you guys remember Rich Softy. He was the Gulf Strike Team person there. And we had a big meeting with all the state and federal agencies and stakeholders and said, what are we going to do? And we said, we think we just do natural recovery, put a little sorbent material out. It occurred in December. The vegetation was already died back, and they agreed to that. So we did go back and look at some places. So here's what it looked like here, right during the spill. Everybody recognize what this is. This is one of those tidal floodgates. So, and this sign says National Wildlife Refuge Boundary. So this is part of the Savannah National Wildlife Refuge Complex. And these are all ponds, old rice fields that host, millions of ducks in the wintertime, but they stay in the ponds because they don't, these are dabbling ducks. So there were like 5 birds affected by this spill. But 2 years later, it looks fine. Remember, the oil was coating on the vegetation. It didn't penetrate the soils. The vegetation was already dead. It was in senescence. And so the recovery rate was pretty amazing. So here's one of the law enforcement officers who we went out with in '84. There was a lot of oily rack material. So this is the sawgrass. This is the freshwater part of the river. And I had him take me out again. And I said, oh, you shaved your beard. I want it to be the same. But he said, I got a girlfriend now. So the beard was gone, but it's the same guy. We have found no evidence of any oil residues 2 years later. Big river, big tides, a lot of flushing. And so seasonal effects, really are important to consider, if you're trying to decide what to do about a spill. When you oil in the winter, when the vegetation is dormant, or whatever season it is, whenever the vegetation is dormant, that's when you have the lowest impact, and especially if you don't penetrate into the soils. When you have it in the growing season is when you have the greatest impact. Oil plants, oiling causes stress, but a lot of times they won't flower the next year or produce seed. And then some of the effects can be delayed by one season because depending on how much of the above ground vegetation died back. So here's a good example of the seasonal importance of a seasonal time. Another example, this was the spill, the Julienne in Portland, Maine in September 1996. This was a combination of a IFO 380, which was the fuel, and then the cargo was a home heating oil. But most of the black oil is the IFO. So of course it happened, spills seem to always occur during spring tide. So look how extensive the oil covered this marsh, right up to the high tide line. I mean, here's the marsh edge right here. Look at that. The entire cover. I mean, this is some of the most extensive oiling that I've seen. And so it into this one embayment here. And of course it covered everything else too. Here's all the riprap just black. That was a really, because the spill occurred just a short distance away, and so it was very heavy loading. So, what we're gonna do? Here's a ground shot looking up that. I'm going to go back. So that picture I'm taking now is taken here, looking up this tidal channel. So what are we going to do? The wildlife folks, they said, well, we have birds that winter here, and we got to cut the oil vegetation so they don't get exposed. And I said, well, we kind of know that the oil will eventually weather, be a non-tacky, and won't be a contact hazard. But well, we almost got in a big fight over it. But we said, so I said, okay, well, why don't we? It was during my bread making days. I said, why don't we just dust the marsh with something to speed the recovery, speed the reduction in contact hazards. And I remember someone told me, oh my God, that's a sinking agent. It's time for you to go home. You're crazy. I said, okay, well, we ended up not doing anything. But a few weeks later, this is what the marsh looked like. It's not died back. It is covered with fine sediment. There had been a 20-year flood, and you can see over here, this might want to go back here. So see, this is a nice vegetated bluff here. Well, there was a big flood, and that bluff got eroded, and all the marsh is covered with fine sediment. So my idea was a good one. God did it. So anyway, so what do you think happened at this marsh? Okay, so here, remember, look how much it is. Look how oil it is, right? Okay, here's what do you think it looked like the following spring or summer? It looked great. The plants were dormant, the oil was thick, but it didn't penetrate the soils. I think maybe the little bit of dusting helped and everything else. And there's ice in the winter, and that kind of ground things up. So it was amazing recovery. And we saw this in other places too. Here you go around the corner where this is a different kind of species. This is Spartina patens. And you can sort of see the shoreline here. And this is 1 year later. There's been no erosion because the oil did not penetrate the sediments, except we were involved in the natural resource damage assessment, and we walked the entire shoreline. We found, I think, what was it, like 95 little patches like this, where the vegetation had died back by the next year. And if you dig around those areas, what we hypothesized, though we never did do the chemistry, I don't know why, that this is where the home heating oil that was the cargo was mixed in with some of the black oil, and that's where it penetrated a bit more into the soils. Okay, so that's sort of a lot of the important things about different oil types, and whether you get oil in the vegetation or the soils, and the natural removal processes and seasonal considerations. So with all those things, we start off with, well, if we have an oiled marsh, what are we going to do? And so this is a page from the NOAA characteristic shoreline habitats selection for shoreline cleanup methods. And so it has information by oil group or oil type, and then then the different kind of response options you have. And then we give them grades. A causes the least impact, and D causes the most adverse habitat impact, from both the oil and the cleanup method. So we start off with these support decision documents. And so really, by the time that if you go through all that list, there's really only a few things you can do in marshes. Natural recovery, but we almost always use sorbents of some kind, including loose organic sorbents. I'll talk about that a little bit. Flushing is harder to do than you think. We've tested in surface washing agents, manual removal, vacuum, vegetation cutting, and burning. I'll go through that. Natural recovery has the least habitat impacts. We've got a small to moderate amount of oil. You've got some good waves and currents and ice. to help you with the removal processes and during the non-growing seasons. But natural recovery can't always be an option because perhaps some important animals are going to be coming into that area seasonally, and you worry about when it becomes a contact hazard for animals using that habitat. And so just a couple of years, well, now it's 3 years ago, the original spill from the Golden Ray in St. Simon Sound, that car carrier that flipped and released not very much oil, but they initially not very much oil, about 1,000 gallons of a heavy fuel oil. So here's some oil on the vegetation in the salt marshes. You see it starting to weather a little bit, so it's just a little bit tacky. And so if you can wait time enough for the oil to be no longer tacky, then natural removal might be an option. But in some places they did not want to wait, and I'll show you what they did later. Almost always, if we have oil in the marshes and there's any oil that's going to be remobilized, we'll put out sorbent material. But you got to make sure you place it properly. So look at this. This is not proper placement. This is actually a big vessel had just gone by and, of course, displaced the water and threw the boom, the sorbent boom, right on the marsh. So, and you got to be careful. A lot of these oils don't really soak into these round sorbent materials. I don't hate to call them boom because there's no booming component to it, but especially the heavier oils, they just coat the outside, so it's going to be nice and clean on the inside. So you have to worry about excessive waste. And so, here's a proper deployment. Here the sorbent is staked in the water, so it doesn't foul on the shoreline. And so that can work better. And the pom-poms or oil snare, they do have a much higher surface area to which the oil can adhere. But you got to make sure that you remove all those. Here's a year later after a spill in Tampa Bay. I was poking around and said, here's some sorbent material left behind. Sorbents can be hand deployed. Here's the Chalk Point spill in the Potomac and Patuxent River, where they're used walking boards and to get access into the interior part of the marsh that was almost inaccessible. So these guys are putting the snare, soaking up the oil. Look how black and thick it is. So you had natural recovery would be very difficult. And so here's an example for the sometimes we've been using loose sorbent material. You have to get permission because most of the time, even if this is a natural sorbent, with the regional response teams, they want you not to leave things in the environment. So you want to have that discussion with them. So here they used spag sorb, which is a dried up bag of moss. And here they are, they're trying to reduce the contact hazard because this spill occurred during times where there are still lots of animals in the marsh. In fact, in Georgia, they're there year round. And so here's a video, I think. Yeah. Here they're spraying the spag sorb. Not very, precision technique, but okay. And that worked okay. We've also used it for as a way to reduce contact hazard after some treatment. So during the Deepwater Horizon, where there was some pretty aggressive raking and cutting of the oil on some of the more heavily oiled marshes, these ones had really thick mousse on it. You had to scrape it off. Here's a little potato rake trying to scrape that oil off. And so at the end of each day, they would cover the treated area with a little bit of bagasse, which is ground up sugarcane stalks to try to reduce the contact hazard. Flushing is always thought to be, a technique that you can try, but it's really hard to do well, and you can do it poorly. So during the Amoco Cadiz spill, there was this one area that got very heavily oiled, Ile Grande Marsh. So there's a little bridge. They were able to close that off, keep the oil from going through the other side, but the oil just pooled in here. I mean, it was like knee deep. And so they declared war on the spill. They brought out the army, and here's the army folks using very high pressure to flush the oil off the marsh surface. And in doing so, they flushed off the marsh soils. So now you're down to the rocky, bare subsoil area. And those areas that were treated took 7 or 8 years to recover. And the ones that they didn't do this recovered in 4 or 5 years. So you can slow recovery if you're not careful with the flushing. And flushing is hard to do because water in a marsh is pretty flat. So it's hard, you have to create some current. So here's that chalk point spill that was from a pipeline that crossed right over here. And it went into it was an interior release, and then it got out elsewhere, but it was really thick in there. And so this was an EPA response. And you look at it, you say, geez, they should have burned that, right? That would have been a perfect burn. You don't see any houses or anything nearby. But what you can hardly see here is these lines, this is the power lines. The pipeline was going to a power plant just a little ways away that supplies all of the power to the eastern shore of Maryland. And so burning was not an option. So here they are trying to, they dug a trench and trying to use high volume, low pressure flushing and leaf blowers to push the oil out from the marsh service to recovery sites. It was pretty ugly looking. During the Deepwater Horizon, there was a guy, a really innovative guy. He was always coming up with new things. He would go back to shop and build something new every couple of weeks. So he came up with this idea. It didn't work because by the time we tried it, the oil wasn't flushable anymore. But this is just a concrete pumping system. You put a little spray bar on there because it's hard to get behind the marsh because you want to flush toward recovery devices. We can't put a header hose and lay it down here and flush it that way. Work from the water. So I always show this because I think one day we'll find a spill where this might be a good idea. And during the Julienne spill in Maine, we noticed that when we were doing the initial scat surveys that the oil could be flushed off the vegetation very easily when it was really fresh. So we said, okay, operations, bring your flushing. Let's get some flushing going. Well, it took them 3 days, and of course by then the oil had weathered and stuck, and no more flushing. We said, okay, well, why don't we try surface washing agents? And so we got permission to do one area here. You can sort of see, here we are spraying it early in the morning, low tide. There's Charlie Henry walking in the back, taking some water samples, a little fog spray, mist spray to wash it. And it actually, from this picture, it looks pretty good. So look over here on this, see how black the vegetation was, and over here it's still black. So here's the place where the surface washing agent was applied. But if you look more carefully, so here's what it looked like before, and then here's after the flushing and the surface washing agent. And this is essentially, it got about half the oil off the side that you were able, because this was a Spartina alterniflora, so it had blades. So you got half the oil off the part that you could spray directly, but the surface washing agent didn't soak around and clean the other side. You'd have to move it all around. And also with all that flushing, we didn't recover any oil. Very little of the oil floated to the surface. So it was very, very difficult. I mean, this is like one of the only places that we thought that we could actually get all the logistics, because there was a seawall and riprap behind there. So it was not done operationally. Manual removal can be done very carefully. Again, Deepwater Horizon showing an area where this was the famous Barataria Bays area where we had very heavy oiling here. I mean, this was a thick oiled rack that was piled up here. Here the vegetation is laid over centimeters of oil. And so we did a lot of tests where we tested different kind of cutting devices. We ended up using this little hedge cutter here and rakes and bagging it. A lot of only working from walking boards, a lot of close monitoring, and this actually worked pretty well. So here's some studies done in this 1 year later, summer of 11. Here's an unoiled area. Here's an area that was not treated. We got permission to have some set-asides. So this was not treated. And then here's the areas that we did the raking and cutting. So it's got some vegetation on it, but you biologists or botanists will notice something very, very important. It's not the same vegetation, is it? This is Spartina alterniflora, and this is a different species. This is, it's a little bit more opportunistic species, but but it is recovering over time with the full normal species. And so here's the guy remember the guy that had the spray bar? Well, he said, well, if I can't spray the marshes, maybe I can rake them manually for you. So he put this little rake on that same arm, and here he is raking it, because look, Ma, no feet on the marsh. You don't have to have people standing there and raking it if you can do it with a remote operation. But it was harder to control. And so what we found was that, again, this is, and 2 years later, here's an unoiled, here's where we did the manual treatment. Here's the no treatment, right? There's still a little bit of vegetation coming back, but here's where these two places were mechanically treated with the scraper arm. And some of the Tulane researchers, we teamed up with them and they did a planting project. So here's where it was just too aggressive. The mechanical scraping just removed too much of the soils. But if they were planted, it recovered better. So here's another picture. This is in 2015, 5 years later. Here's the oiled, this is oiled control. Here's the mechanical treatment and mechanical planting back there. So you can see that mechanical treatment, the vegetation died back, and look at the shorelines eroded by about 1 meter compared to the planted and then the oiled and not treated. So impact and cleanup, you can just destroy the root system under trampling. I mean, look at this picture, isn't that awful? You can mix oil deeper, you can remove surface soil, and you can cause smothering. So we try not to do this. Vegetation cutting is something that we have done in the past, and it's been done about 30 times. We did a literature search. So here's a spill in the Cape Fear River that we worked on, that a cleanup contractor went out and started cutting the old vegetation before the scientific support team showed up, and we made them stop, but they had done some areas. So you can sort of say, here's the cut vegetation. You can, only in places where they cut did we see the oil, sort of on the substrate, because they just were doing it poorly. And so here's that area that was cut, went back 2 years later. There's very little vegetative, no vegetative recovery essentially. Whereas areas that were heavily oiled and not cut, came back. So and then here's another spill in the Delaware River. Pretty heavy oiling on the vegetation. 2 years later, good. The Delaware River has both good river currents, a lot of boat wakes. So and here the substrate's very muddy, so there was no oil penetration. But on the other side, the state wanted it to be cut because they said it was an important bird nesting area. So they had cleanup crews go out there and whacking it. What's this guy doing? Smoking a cigarette or something? So there's no PPE. This was in '85, and 2 years later, no more oil, but no more nesting habitat either. And then another area was done with a little bit more care. These guys have PPE on. There's some riprap along the edge here, so there's protection of the marsh. And that one recovered pretty well after 2 years. So cutting it's not always good, it's not always bad. It just kind of depends. Sometimes we'll allow cutting to get access to the oiled area. So here's a Phragmites marsh in Louisiana, where there's a pipeline release. And so in order to get access in that dense Phragmites, they had to cut some paths to get access. So you got to consider when the oil will weather and become not sticky, and that it might delay habitat recovery. And if you got to keep foot traffic off the marsh. Okay, I think I just did this already. Okay. Oh, I know. Here's what I want to talk about here. So planting. We just revised the NOAA marsh job aid for response considerations, and we make a big argument for emergency, for planting as part of the response, not part of the NERDA, but part of the response. Because look at this planted area. I mean, it came back so well. And then during the chalk point, what they because of all the deep vegetation and trenching they did when they were trying to get rid of the oil that was inside this marsh, they filled the trench and then planted it. And 1 year later, look at that. It's amazing. I mean, and that was pretty heavily oiled, but they brought in some clean soils and spread it all, buried took the oily stuff and put it in the trench. So it looked amazing. Okay, so I'm going to talk about I have one more section to talk about in situ burning, because that's a tool that is used quite a bit in Louisiana particularly. So I'm going to talk about the Louisiana case studies. So these are 8 case studies from 2000 to 2019. 3 of them are condensate, and the rest are South Louisiana crude. And so here's one of the first ones that I worked on. This was a condensate spill. We burned it 7 and 8 days after the release, because that you would think that the condensate would evaporate, but it got trapped in that vegetation. It really does slow evaporation. And so so here we are. We did a test burn on this side. It burned up really well. You see this little circle thing right here? Well, that was our fire break. Well, it's kind of hard to do a fire break and during a spill. And, we had taken an airboat and wetted the vegetation, but it just went right over. It went all the way to water here. But boy, that condensate burned clean. There's no oil left behind after that on the surface. And so here's the red outlined area is where the oil was. Oh, yeah. And yeah. So here essentially we burned 10 times the amount of marsh that were oiled. But one thing is that, right after the marsh burn went out, we rushed out there to look at it, and we looked around and we said, look, this is a little crab burrow. And if you look inside the crab burrow, there's some oil in there. Because remember, when you burn oil, when you burn oil, you heat the oil and then the vapors burn. And so the oil that was below the ground did not get heated enough to vaporize, and so it didn't burn. So that's going to work. Here's another case study, and Phragmites, it's pretty resistant to burning, but so you can see here the oil didn't even get beyond all the way to the fire break that was put down. So it just burned to the edge of the heavy oiling. But boy, it should burn through the ground, didn't it? Here's a site where they did burning up. There's another pipeline release in the middle, and the recovery after just the next growing season, you can see the vegetation. This is a Scirpus bulrush type, except right where the release was. Look at how good the vegetation looks around here. This is the oiled and burned. Here's another one, another pipeline release in the middle of the marsh. In December, this is the area was oiled, and the outline tan area is what burned. And then we went back in the next fall, and you can see here the vegetation, except for right at the release site, which is where, because this was a pipeline below the surface release site, so it soaked up through the soils, and it was really bad. So lessons learned is that the burned area can be much larger than the oiled areas. The potential for a larger burned area should be explicitly considered, especially if they haven't been burned before recently, where fire breaks can't be completely cleared, there's not a lot of freestanding water, or with dry or dead vegetation. And all of these burns were on the interior, not the infringing marsh. Vegetation recovery usually occurs within 1 or 2 growing seasons, where you can change the plant species for a time. It's very appropriate for small spills and marsh interior where you really can't get in there. And we prefer a water layer, but it's not required. But you really want to have saturated soils. It can be done weeks post-spill, but it won't prevent the injury that occurs from the prior oil exposure. So there were a couple of case studies which I condensed here, where the oil killed the vegetation before we got a chance to burn it. There may be burn residues, especially for the crude oils, not the condensates, that require some post-burn removal or raking. Oils that penetrate in the substrate or release below the marsh surface will persist. And so you want to select the in situ burn option early to prevent damage. And so I'm getting close to the end. So here's the latest graph from the revised marsh job aid that we just finished up for NOAA. These are years to recovery. And there's a lot of detail here, but we have light refined oils. When they're really heavy oiling here, you 40 years or more for recovery. Very heavy oils where there's no shoreline cleanup. But most marshes, look at this, but even depending on either whether it's a heavy refined oil or crude oil, recovery for half the spills was within the first 1 or 2 growing seasons. And then there's reasons why these other ones took a little longer that we've captured. So longest recovery for when you have spills in cold climate, sheltered settings, got a lot of thick oil on the marsh surface. We have light refined products with heavy loading. If those thick residues really will slow recovery, and if you have a lot of intensive treatment. And shortest recovery is for warm climate, light to heavy oiling of the vegetation only. Medium crude oils seem to be more degraded more readily than heavier crude oils or refined products. Less intensive treatment, and recovery is usually less than 1 or 2 growing seasons. And so here's the cover of the new marsh job aid that's it's almost ready to be published. And I think I'll take questions now. Thank you.
Yeah, thanks, Jackie. After these talks, I'm always reminded about how much information is in the talks and passed on to others, and it's such a Lynn and I we're getting pretty good at it, and we're getting pretty efficient at it, but we put some time into deciding who we're going to invite to speak, and then putting everything together. But it's very much worth it, and a talk like this really reminds me of how the little amount of effort we have to put in it makes an important difference, because we're capturing this information, and it's information that you've gained that I'm not sure is going to be people aren't going to go out and do the research projects that you did back in the 70s and 80s ever again, I don't think.
No.
And so your firsthand knowledge is really valuable, and I always think that Lynn and I are running out of good speakers to invite, but we're not. We still have a very robust set of speakers coming, and this talk was really fantastic. So once again, thank you for doing it, and I'll give some time for people to put up some questions. But before I do that, I just want to remind we have another talk in December, and so Roger Prince will be talking about some of the dispersant use spills that have or lack of dispersant use spills. So he's going to be just talking about the history of dispersant use in December. Then we're going to take a month off in January, because we want to come back immediately after the new year. And in February, we have Ken Lee is going to give us a talk. So we have a couple of good presentations coming up, and we still have people planning. We have on the schedule for the first couple months of next year, past February as well. And beyond that, maybe the second half of 2023, we still have plenty of open slots. So I'm not sure I've asked this before, but people are listening in. If you have some ideas for people that would give this type of presentation, send them to Lynn and I, and we'll see if we can get them on the list. So we're getting a lot of questions, as I expected what happened, but I wanted to ask, I take the privilege of being the moderator here to ask the first few questions. And I saw one interesting thing, I think on slide 3 or 4 on your, maybe it was the Matula spill, you had a plane sitting on the beach. Is that how somebody landed on the beach? It didn't look like it was a float plane. So somebody landed that plane on the beach, and you got off and did your thing and got back on the plane.
Yeah. No, that was in Lower Cook Inlet, and that's how you get there. You can't. There's no roads.
Yeah.
So
Okay.
so yeah, but we've landed on lots of beaches, but you got to be very careful. You got to hire the right pilot.
Yeah. Well, that's key. And I'm sure there's plenty of pilots in Alaska that know how to do that. Yeah. One thing I wanted to ask though, Jackie, is I know that biodegradation is the fate of the vast majority of oil, especially the stuff that's not picked up or burned. But you didn't speak too much about, I just think about these marshes as kind of getting really saturated with oil, and that means they're going to certainly go even more anaerobic than they would have. And then, marshes probably have a lot more nutrients in them than certainly the nearshore or the offshore. But you didn't talk about nutrient addition, or maybe even beyond that, oxygen addition to speed the biodegradation process. What's your experience with that? Is there a reason that these heavily oiled marshes wouldn't benefit from adding nutrients and or oxygen to help speed the natural recovery process?
Yeah. Oxygen's the limiting factor. These marshes have plenty of nutrients, and I think Ken Lee and some other folks have done lots of studies where they added nutrients, and really, it's you can stimulate the plant growth. You get better plant growth, and that might increase the oxygen. As the roots, as the plant continues to grow. So, but it's hard to apply those things when the tide goes in and out twice a day. You can't get enough of it to stay in there, and so and then it's hard to inject it there. They've done some experiments in mangroves in Australia, where they tried to inject oxygen and you just can't, in the muddy soil, you just can't really, get it to diffuse out there. So.
So
And also on the chalk point spill, I didn't show it, but because it's some data is complex. But remember that one that was the pipeline spill in the middle with the in the Patuxent River, and they did all the trenching. Well, somebody from EPA went, "Oh my God, we got to add nutrients." I said, "Okay, you guys can add nutrients, but you're gonna have to do a study to show add nutrients here and not here, and let's see who does better." And in terms of the oil weathering, and there was no difference.
Okay. So somebody needs to
So
figure out a way to get oxygen to stay in these areas, and it's the tidal, in the next tide, all the if you add water, oxygenated water, the next tide it's gone. And so that makes sense. Okay, well, look, we got a lot of questions here, and if you want, Jackie, you can pull up your Q&A window and we'll go through them. But first question here is, how do we get, and we're trying to keep the questioners anonymous, so I know you can see the questions, the names of the questioners, but I'm just going to ask the question without identifying the questioner. But so how do we get the NOAA job aid? Is the first question.
Well, it's not quite published yet. I'm waiting for, but you can go to all the job aids are at response.restoration.noaa.gov and just type in job aid or Marsh job aid. It will be there. And the principles do apply to, I think freshwater and most of the principles apply from saltwater to freshwater. Some of those, all the case studies I showed were not just salt, I called them marshes because, but
you're reading ahead, but I think I'll ask the question so everybody knows.
Oh, that's right. Okay, exactly.
I'm not sure the attendees maybe they can see the question. Do the same principles apply to freshwater, marshes, and you just answered that. Okay, next question. Why not treating the marsh as completely damaged? Remediate using surface washing agents and then add soil.
Because we never know for sure. These days, we know how to do things to make it better. We don't let the oil sit there for a long time. So these case studies have informed us, and so I haven't been to a spill where a marsh was completely damaged. Except for in Barataria Bay during the Deepwater Horizon, we did a lot of specialized treatment and removal and scraping and planting. So I think that's I don't worry about the surface washing agents. Might get some off the vegetation, but that's not going to save the plant necessarily. And then it's not going to work if there's a thick layer on this marsh surface. That's got to be removed somehow. So I think we're trying to prevent that totally damaged, degraded marsh by being more proactive during the response.
Okay. Next question. How do you get involved in directing cleanup at spills? For example, are you invited into the command post to make recommendations, in the environmental unit to make recommendations? Do you go to the spill and ask to do research or something else? You're invited.
Yes. Well, since 1978, my RPI, my company, has been under contract to the National Oceanic Atmospheric Administration, Office of Response and Restoration, what they're called now. And so the Coast Guard, under the National Contingency Plan, the Coast Guard calls in the NOAA Scientific Support Coordinator when they need help. And so we are always part of that team. We respond to between 50 and 100 spills per year. Now we don't jump on airplanes, or hardly any of them anymore. We can do a lot of remote support, but yes, we will take positions within the environmental unit, be the SCAT coordinator, do all the recommendations, best management practices, write a lot of shoreline treatment recommendations, develop cleanup endpoints, and do the whole shoreline thing.
How many employees do you have at RPI? You mentioned you have a Saudi branch. Is there other branches worldwide?
No, we have a team of 3 people in Saudi, but right now with their team, I'm going over there on Thursday, and we'll have a team of 10 doing some big field work there. But the company Research Planning has 22 employees.
Okay, that's great.
Yeah.
Okay, I agree with Tim. Great talk. Next question: what is the general opinion for the appearance of opportunistic species? Are they a part of the process of repopulating the soil, or are they referred to as irreparable damage?
I think that they are, we will take any vegetation if you're thinking about opportunistic vegetation species, yeah, any vegetation to stabilize the soil, because unless you've changed the elevation or the topography of the marsh, we expect to have the natural community come back.
Okay. So these opportunistic species may stay there a season, and then the
Yeah.
natural vegetation will start working its way.
Right.
They can't outcompete the natural
No.
vegetation for long. Okay, as always, Jackie, nice job. Thanks for the update on ESIs and oil spills and marshes. Great talk. Next, never fails to learn something new when listening to Jackie speak. Thank you. Okay, question: what ESI ranking do estuaries have?
Yeah. So we don't actually, we have shoreline types. And so within an estuary, there'll be exposed tidal flats, sheltered tidal flats, fresh and saltwater marshes. And so that we don't call them, we don't classify them as estuaries, we classify them as the shoreline components within that system.
Okay, makes sense. Great talk. Next, great comment, I guess. Great talk, and I'll share it with my colleagues for sure. Thanks for sharing your experience. And then finally, thank you, Jackie. Yeah, so those are the questions. If there's more questions, we certainly have time if people want to continue to ask them. So I have a couple other questions I was going to ask. One is these environmental sensitivity index are there's probably a number of factors, but the two primary ones that go into the ranking is the amount of biodensity that shoreline type has, and then you factor in recovery. Are those the two primary factors that you use to assess the ranking of the shorelines, the sensitivity?
No, it's a degree of exposure, because remember, rocky shores, an exposed rocky shore and a sheltered rocky shore often have very rich biological communities, but an exposed rocky shore hardly ever gets any oil on it because the oil doesn't strand on it, whereas the sheltered rocky shore does. So it's exposure, grain size, which affects penetration and burial, and then biological productivity.
That these exposed rocky shores are so energetic that the oil may hit them, but it's not going to last very long.
No.
Except if it finds a deep pocket, I guess, right? Some of these rocky shores in Valdez, I know they can still go back and find oil there. But okay. Yeah, we got a lot of comments about the value of these talks, and I will say that these talks are we're recording them, and it takes us a few weeks, but they get loaded up onto an API website that contains all of them, and so this talk will go up on that website soon. So if you want to go back and look at it, and I learned we've had them on the API website for over a year now, and so we're starting to get some pretty good statistics, and I think we have they're getting several thousand hits.
Wow.
So people going to view the presentations, which is great. Unfortunately, we shouldn't have captured this, but we capture how long people actually spend each time they look at a video, and we have, I think it's between 2 and 4 minutes that people look at videos. So nobody's going in and listening for the hour and a half to go through it. I think we know that there's only a handful of those people that really spend time at it. But I think that's kind of the beauty of these recordings, is that you can slide through and and try to find things, especially because we have these slides. I've done that before. It really makes it easy to this is the kind of topic I'm interested in, and you can slide through and find the slide that you think is interesting. And then, so 4 minutes is it, when I first heard that, I'm like, oh, only 4 minutes, but I think people can actually go through, and they need a bit of information, and they can go to especially a talk like this, they can go to a slide and see when it pops up when you scan through with the slide to move through the video, and find really targeted information. And so I do believe that recording is valuable, and allows the people that are really hardy to go back and listen to the whole thing if they want. But we are thinking about generating, because we know that we're in the kind of YouTube, TikTok generation here, and that attention spans are at most 5 minutes and maybe not even that long. And so we are considering trying to get some resources together to go through the talks we already have and generate what we call, like a movie has a trailer, and so a trailer for these talks. So people can, they're 2 to 4 minutes. We can go through and have somebody, maybe the speakers go through and tell us what they think are the most important highlights of their talk and make a 2 to 4 minute trailer of each one, and then that would also allow the person that watches the trailer to maybe target parts of the longer talk that they want to listen to in a little bit.
That's a good idea.
So we're looking at that. So we may be back, and I appreciate comments from people on that idea. I think it's a worthwhile thing because it is tough to spend that. I mean, we appreciate the audience we have, because I think this is, I think we had almost 90 people listening today. I don't know if you saw that, Jackie, which I think that's getting above our last few months average. So you've drawn in more attendees than we have in the last few talks, which is great. But I do think it's worthwhile, and we actually have more ears for these talks than we, as I said to you earlier, we have more ears on these talks than we would get if we were speaking at a session at IOSC or Clean Gulf or other places.
Yep.
And so we do get to transfer these messages to a broader audience than we might if we spoke directly at a session. So I do think it's worthwhile. Let's see, before I let you go, we do have one last question here. Have you had resistance in promoting natural recovery to the public who want to see something done?
Oh yeah. But all you need to do is show some, that's why this job aid that we just recently updated, a lot of the pictures that I've shown in my talk are in there, and you show that to them and say, listen, this is our experience, this is what we think can be done, and here's what you can do to make it better, and here's some things that you talk about doing that might make it worse. So yeah, it's a lot of communication and trust building takes place.
Yeah, you mentioned it, and Roger Prince gave, and he's going to give this talk in February, but the pictures he has from some of these oiled shorelines and comparing that, right? You can have a graph of your Spartina and everything else, and you just don't, if you're an objective scientist, you can get it maybe from those graphs, but the pictures are really powerful. And it's great that you understand that, because these talks that show the pictures of before and after and how old it was and how quickly things can recover really are the best way to get that kind of message that, look, if we do this, here's what's going to happen. And look, here's the picture that explains it. And you could show them a ton of graphs of the recovery rates and everything else, and it wouldn't sink in as easy. So I do think that's a powerful tool, and we get that photographic evidence from somebody like you who's been out in the field taking those pictures. So
yep.
Great. Well, again, Jackie, I don't know if you have some final thoughts or comments you want to make, but I appreciate your time. I know that it takes time to at least pull slides together, because I know you give a lot of these talks, but pull these slides together and get ready for this specific audience. So we really appreciate your efforts to do that, and this was a fantastic talk. So if you have any final comments, Jackie, I'll pass it to you. If not, we'll let everybody get back to their day.
I just want to say thank you, everyone, for attending. I'm an oldie but goldie. I've been doing this for a long time, and I love it when I can share my experience, and so people can go out. I always want people to make new mistakes.
Yep. Okay.
Thank you.
Thanks, Jackie. Thanks, everybody. We'll see you next month.
Thank you.